And that's about it from me. So all that's left for me to do is introduce our speaker, Ian Hyde, who's the Engineering and Safety Director at Chiltern. Though I remember, Ian, we met not at Chiltern, on one of your previous projects.
Thank you, Tom. Hopefully everybody can hear me okay. Good afternoon, everybody. Well, thank you for coming along to attend and to listen to my presentation about HybridFLEX, our trial train at Chiltern Railways. I've got quite a few slides, but you'll be pleased to know there's pictures and videos in amongst that, so it should hopefully move along fairly smoothly. So there you go, to start us off, HybridFLEX. It's one of our Class 168 units. It's part of the Class 170 Turbostar family. So many numbers of those vehicles in operation in the UK today. And HybridFLEX is a diesel battery hybrid train, so can operate on batteries in stations and depots, but on diesel power on the main line. So what I'm going to talk about this afternoon is something a little bit about Chiltern, why we have a need for low emission trains, how the project HybridFLEX was delivered, something of the technicalities of it, the challenge of building and testing through COVID, and progress to date on our mainline operation trial and future opportunities. So at Chiltern Railways, people may know we're a small but perfectly formed operator. We have an all diesel fleet, and Marylebone Station, our London terminus, is the only all diesel London terminus in operation now. So clearly we wish to decarbonise and clean up the air for our station, our customers, staff and near neighbours, but of course it's the right thing to do for the environment and our planet as well. So Porterbrook, who own our Class 168s, a number of years ago started this project to see how they could decarbonise their fleet, because as I said, there's many number of Turbostar vehicles around in the UK. Almost in parallel, we worked with Angel Trains, who own our Class 165 fleet, to do a different diesel battery hybrid train. And I'll talk a little bit about that later, but the main topic is HybridFLEX, our Class 168. So people, I'm sure, are aware of the legal obligations to decarbonise. You know, the challenge to be for the UK to be net carbon zero by 2050. But of course, it is the right thing to do for our people, neighbours, customers, etc., to improve their quality and life and health. Now, there's been various pieces of legislation, commitments, reports for how to decarbonise. And, you know, the traditional way to decarbonise the UK railway is to electrify the lines with overhead lines, operate electric trains, and generate that electricity from green means. So that's the traditional way. But in our engagement with Network Rail, GBRTT, the plans for electrifying the Chiltern route are, you know, late 2030s, possibly 2040s, and possibly beyond. You know, we can all create plans, but we need the budget to fulfil those. And of course, budgets are challenging across the UK and the world at the moment. So what can we do to decarbonise? And before we get electrified lines, well, this is one of the big opportunities. The traction decarbonisation network strategy, again, quite a mouthful, but does support electrification of lines. But again, there's whilst that is the future strategy, there's no current funded plan to be able to do that on the Chiltern route presently. The DfT Transport Decarbonisation Plan does promote the use of technology to clean up diesel trains, and HybridFLEX, as I mentioned, is a diesel battery hybrid, but it's got a newer stage 5 compliance engine fitted to it. So it's not only got battery power, but is a cleaner, more modern diesel engine as well. So this just kind of summarizes the landscape around us that we're operating within. So we know a commitment to have no diesel only trains on the network by 2040, and of course total effectively net carbon zero by 2050. Just looking a bit more locally around Chiltern Railways. So Marylebone, as I mentioned, is our London terminus. It is a very residential area. There are apartments, businesses, schools, colleges very close by. So when our trains are in the state or approaching and leaving the station, and even when they're idling at the station, there's clearly fumes and noise being emitted that can deteriorate people's quality of life. So there's quite a vocal local residents group that partner up with Westminster Council and local MPs, to rightly lobby us to try and clean the air and decarbonise. So quite a bit of pressure around that. And here is our Marylebone residents group photographed on the right hand side there. So we do work closely with them, and clearly they're very encouraging of the HybridFLEX trial that we've got underway. So a little bit of history about diesel engine emissions. This graph shows the various stages of Euro compliant engines, hydrocarbons, nitrogen oxide emissions and particulates shown. So we can see how dramatically emissions are reduced as we've progressed through various stages of compliant engines. But people may know that rail vehicles weren't actually within the scope of this legislation. So unfortunately, our current diesel engines don't even comply with stage 1 of these levels of emissions. So 1997, the non-road mobile machinery directive came in, stage 1 and 2 requirements, and I say rail was accepted from those. Chiltern actually bought our first 5 Class 168 units. People may recall, thanks to Adrian, that it was the first procurement of new trains after privatisation. So 1998, this was the time of, still within that stage 1 and stage 2 requirements that didn't even apply. 2004, we're moving on to stage 3A and 3B, and that is now extended to rail engines. The last turbostars of the family 168, 170, 171s were built in 2005. 2010, 2011, Class 172 turbostars were built, so they were stage 3A compliant. But here we come right up to date from 2016. There we've got the toughest emissions level there, so you can see dramatically reduced from what they were in stage 1. So the HybridFLEX, as I mentioned, does incorporate a new diesel engine that is stage 5 compliant. So the benefits of HybridFLEX, as I did mention, it operates on batteries in and out of stations and on depots. So effectively, it's zero emissions at that point. Acoustically, very much quieter. But then even when it is in diesel mode, those emissions are very much lower than the diesel engine that it replaces. We've fitted a new mechanical transmission and regenerative braking, so it's even more efficient when in operation. So the theoretical computer modelling was to use up to 24% less fuel on one of our typical London to Birmingham journeys, 41% less friction braking energy, around 25% less carbon dioxide, and around 70% less nitrogen oxide emitted as well. So dramatic improvements in the emissions. So they were the objectives. Now I'll talk a little bit about how the project was delivered. And it was back in 2018 when Porterbrook partnered with Rolls-Royce Power Systems to agree the development of HybridFLEX. So, following quite a traditional engineering project, you carry out a feasibility study through various levels of detail through to a concept design in 2019, really pressing through into how we could fit all this equipment onto an existing turbostar train, working through detailed design, gauging, braking, calculations, etc., to make sure it was compliant. So once we had a final design, we were ready in 2020 to start to convert our Class 168 unit. So that was Q3 2020 into COVID. So you can imagine the challenges of social distancing, people remote working, how we would physically do that work. But the team and various partners really worked very closely together to make sure it happened. So by early 2021, we were ready to do single car testing at Gemini at Wolverton. Into Q2 2021, we were ready to do some track testing at the Ecclesbourne Valley Railway and the Tuxford test track, which brought us through nicely to mid 2021, which was actually the 25th anniversary of Chiltern Railways. So we used the unit to both celebrate its operation and celebrate 25-year birthday. After that, we did do some upgrades to the power packs, and we rolled out more driver training such that by the start of 2022, we were ready to do passenger operation. So now we've just clocked up a year in service to bring us here to this IMechE presentation. The project is a real glass case example of collaboration and partnership in the rail industry. So these are the main partners. As I say, the owners, Porterbrook, really were the funders and central project management function, but bringing through Rolls-Royce Power Systems, ourselves, Chiltern as the operator, Gemini, the installers, new designed braking and control system from Wabtec, and installation and design approvals by Ricardo. And this is a longer list of, as you can expect, many other suppliers and partners supporting the project, so many from across the UK. So a little bit of the technical design. They always say don't apologize when you're making a presentation, but I wasn't involved in the detailed design myself, but so I'll do my best to explain it to you. But at the heart of HybridFLEX is that MTU power pack that's essentially that stage 5 compliant engine with battery pack and electrical machine and control systems. So that's quite a sizable piece of kit to fit underneath an existing train, as you can imagine. We did need to change the braking system from a pneumatic to a both pneumatic and electrical braking system. So there's a new brake control compressor system. And of course, we had to remove the existing engine raft, alternator and silencers. Schematically, this is how the design looks. So, one power bogie per vehicle on the turbostars. So a new transmission system with a retarder, a new intermediate gearbox, which can either be powered from that new diesel engine or from the electrical machine powered through the traction batteries and the 3-phase converter. So the electrical battery supply can power both traction for the unit and the auxiliaries, obviously the heating, lighting, air conditioning, control systems, etc. Some facts and figures comparing what was a standard Class 168/3 unit and HybridFLEX. So we tried to minimize any weight increase, but unfortunately with that extra kit, there is a small weight increase, but we did manage to keep that relatively low and quite minimal. So just some photographs of the equipment. This is on the underframe, a control system. So you can see we can operate in diesel mode, boost mode, a normal, which is both electrical and battery, and what's called scavenge mode, which was if we did suffer a diesel engine failure, the unit can still provide electrical power to itself through the regenerative braking system. This just really describes how those mode switches operate in the body end cupboard. Kept away from the driver, we've minimized any driver interaction or changes with the HybridFLEX system, such that their job is kept as easy as possible. I won't read through that, but essentially the switching between battery power and diesel power is controlled by GPS. So we've geo-fenced around our main stations to ensure that we can switch seamlessly between battery and diesel power, again, without needing to trouble the driver with any of that. I mentioned the scavenge mode again. The modern turbostar units can cross feed. So if you had a two vehicle unit and one of the diesel engines failed, you could still provide that auxiliary power to the other vehicle, and HybridFLEX is able to do the same through, as I say, regenerating through the electrical machine. A little bit more text about that, but one of the other benefits of having the battery power and operating in battery mode at stations is you can provide the heating, lighting and cooling when customers are boarding and alighting at stations. So previously, if we shut down the diesel engines to save fuel and stop emissions, then effectively you would be switching off the heating and lighting, unfortunately. But HybridFLEX is able to keep that hotel load going whilst the train is stabled, waiting to depart its next journey. I mentioned we fitted a new transmission system, so it's similar to the Class 172, more modern turbostar, so that does help both acceleration and fuel efficiency. Some more photos of bits of the train, because obviously you can't see the real train itself during this presentation, but changing the brake raft, as I said, was quite an intrusive change to the system to make sure we were able to do regenerative braking. So a little bit of technical detail about braking levels. We try and use the electrical brake as much as possible, but there is a capacity limit of the electrical machine. So at high speeds, we do still use pneumatic and friction braking, and then blend that in with a higher level electrical brake, and then blend out the electrical brake as the train slows again. So perhaps this graph on the next page shows that a little bit more clearly. So if we had a brake demand shown by the green line, then effectively the blue line is the dynamic electrical brake that can ramp up as speed reduces. So it builds up to the maximum level it can provide, and then drops away as the speed approaches zero. And then correspondingly, the air friction brake applies quite high, but we feather that out as the electrical dynamic brake steps up. So quite complex interaction, but it does mean that we're able to regenerate as much of that kinetic energy into battery power. People may be aware that modern WSP systems are pretty clever and will apply more braking to the different bogies on the unit. And of course, HybridFLEX blends that equally cleverly as well, because we do only have that one power bogie per vehicle. Therefore, the electric brake is, when it's operating, is only on that power bogie. So we do need to, again, interface between the WSP system, the air brake and the electrical brake quite cleverly. So I describe how the brake cylinder pressure has changed with speed, and that could be quite disconcerting for the driver, who's normally applies the brake lever and sees brake cylinder pressure build up. So one of the small change we made to the driving cab was to add a deceleration gauge, such that they can see whether it's electrical dynamic or friction brake, they see a consistent level of braking. And here we have a photograph of the desk. So we've got the speedo and brake gauges, but just to zoom in on that deceleration gauge. And I've got a short video to hopefully show you how that operates as the driver does brake and accelerate. So you can see the blue bars on the left just over the driver's shoulder. You may see changes in brake cylinder pressure along with that deceleration gauge moving as well. So a little bit more about the conversion. As I said, we did have to remove quite a bit of kit off the existing train to install quite a lot of the new kit. So the surge reservoirs were needed to be moved because here we show the new power pack with the traction batteries, AdBlue tank, the new diesel engine, cooler groups, pardon me, electrical machine, etc. Quite a lot of new kit squeezed on there. Quite a big space envelope. So you see the red crosses on the surge reservoirs that we then replaced and replaced the compressor as well, which is at the vehicle end. So onto the build, which I said was quite a challenge. So again, some photos I'll move through fairly quickly just to show you how equipment was taken off of the underframe. Here's the power pack itself, which is, as I said, quite sizable, but it is modular, which obviously has benefits for conversion and future maintenance. A different shot, opposite side. New brake gear, again modular to connect up. Air reservoirs, etc. This is the electrical box inside the saloon. So we tried to obviously minimize any encroachment into the passenger space, but just to show you, it is quite necessary with all those wires and connections that then go down to the power pack underneath. Body end cupboards, again, quite a complex area of a class 170, but we had to interface with that pretty carefully. You know, the vehicles are 10, 15, 20 years old, which presents certain challenges as well as things wear out, but a very competent conversion as well. So once the vehicle was physically converted, I'm sure people are aware of all the testing and approvals that you would need to go through for any new or converted vehicle to prove that it's standards compliant or compliant with the infrastructure, compliant with other trains. I won't read through this word for word, but, you know, basically electromagnetic compatibility, standards compliance, various stages. So here we are testing the engine at the test bed before fitting. Various other bits we tested as much as we could on the test rigs to inform the design. And this is the first single car operation when it was first converted. So may not look too dramatic, but after a couple of 3 years, it's, you know, reassuring to see it moving under its own power. Okay, low speed, but clearly we were very happy when it did move under its own power, and then again back into the shed. Quite an echoey shed, but on electric power, I think you can tell there's quite a dramatic reduction in the noise.
That's the speed farting and pushing it, mate. Good, isn't it?
So pleasingly unspectacular. So then it came, we needed to move it to a test track, and it was, as I said, the Ecclesbourne Valley Railway in quite a picturesque village just north of Derby. You can imagine the challenge of trying to get vehicles there. Just a short video, but you can see how narrow the roads are, and I imagine the neighbours weren't particularly happy on that particular day. We deckled the unit to make it look different and attract interest from customers. So outside in the rain and the hail as well as the sunshine. I think we could operate this 25 miles per hour on Ecclesbourne Valley Railway. Clearly in diesel mode there. We needed to operate up to 40 miles per hour, but we were restricted at Ecclesbourne Valley, so we did move to the Tuxford test track to do some higher speed testing.
A big team effort. Thanks to everyone who's done the work so far. Really looking forward to seeing this operational in service for customers from September.
So we took the opportunity to do a little bit of publicity, as you can imagine, on that testing up to 75 miles per hour, I think it was, at Tuxford. So, as I mentioned, we took the opportunity to launch it, HybridFLEX, for our 25th silver anniversary of Chiltern Railways. So here's my boss, Richard Allen, the MD of Chiltern Railways, his boss and his boss's boss, and etc. People from Porterbrook and Rolls-Royce. It was a real, as I say, collaborative event. We did make some, effectively the design has been developing, so the power packs were trial power packs, but we've made improvements to the design and the maintainability as we've learned more about the unit. So we did do a power pack upgrade in 2021 before it entered service in early 2022. It's a great piece of kit, and I've talked about the environmental benefits it will deliver, but I also mentioned how it's a kind of a glass case example of collaboration as a big rail industry project that has used so many suppliers and partners, and Porterbrook were successful in the Railtech's collaboration award. We launched it into passenger service February 2022. So here we are at fairly chilly Marylebone, launching it and promoting cutting emissions. It generally operated on a fixed diagram on weekdays in and out of our Aylesbury area, so that it was never too far from our maintenance depot. And of course, only having one unit, we needed to create a pool of drivers and maintenance staff who were competent to drive and look after the unit, but be able to maintain their competence as well. So it's a balance of as many miles as possible to stretch it, but keeping it close to home so that we can support the unit.
We're travelling on the first passenger service of the HybridFLEX train. It's a 20-year-old diesel train that we've converted to a battery diesel hybrid. It's got a very powerful battery underneath the train that makes it cleaner, it makes it quieter, and it makes it faster than the diesel trains in the rest of our fleet.
The hybrid power pack basically consists of the engine itself, the diesel engine, and the energy pack. That's what we call the battery pack, and of course the transmission for the train and all the ancillary systems that you need to operate the train, like the cooling system and also the exhaust gas treatment system. So it's a very compact power pack that is underneath the train, and including a battery.
Effectively, the system operates on GPS, so it's geo-fenced around a station. The train knows when it's approaching a station and will switch from diesel to battery power, operate silently into the station, and then power away from the station silently on battery again. The system knows how much charge is in a battery, so if for some reason there wasn't enough charge in the battery, it would continue to operate on diesel power for a shorter distance of time to recharge and then make sure we have enough battery electric power to restart at the right time.
So the diesel engine on its own already fulfills the highest diesel emission standard, and you can definitely also use the pack without the battery. But the battery obviously brings in the benefits of recuperation. So when you break the car, you get the recuperation energy, which is otherwise wasted anyhow. And the battery pack brings in the benefit of the noise. So in the stations, as you could see just now, there's no noise. And also because of the recuperation, you saved also from the air, the pollution coming from the brake pads. So the brake pads also generate dust, but with the battery recuperation, you can also save the pollution part. I think in general, obviously, we have both technologies. So we both have the pure diesel technologies, but on our way to net zero, we want to definitely do a lot more hybrid and maybe even going to electrifications, and in general we want to make the whole propulsion technology cleaner and climate friendly.
On battery power, the unit can operate for, say, a mile outside of a station, in the station, and then accelerate away from a station for about a mile. Again, we're proving the theoretical parameters during this testing, and we'll be testing throughout the spring, summer, autumn period to make sure we capture all that the UK weather can throw at it, to prove the technology, prove it works, prove it delivers the benefits that we expect. We'll be running it throughout this year to prove the technology works, gather data, prove the performance and assess the business case for the unit. It's forecast to save 25% of fuel on each journey, reduce nitrous oxide emissions by 70%, reduce noise by 75%, and reduce particulate emissions from the engine by 90%. So it's a fantastic piece of technology that is really going to deliver cleaner air benefits, less carbon consumption and quieter journeys.
This is the first HybridFLEX train in service, and we'd love to see more of them running around on the network, working closely with our partners at Chiltern to see if we can make that happen. These trains are a really good platform for passenger services. The configuration of the train is good, of the 1/3, 2/3 doors. So we think these trains have got a really good future. What we're trying to tackle with this project is about decarbonising and reducing emissions, so that transition to full electrification or transition to battery trains across the network can happen in parallel to doing something like this in the short term. The next step really is working on the fleet rollout plans, the timing of those, working with Chiltern and looking at the business case and evaluating that with the Department for Transport as well. This technology could be applied to more turbostars, to other fleets, to new build fleets as well. So we're working really closely with the partners at Rolls-Royce, looking at other opportunities and how we can make the most of what we've done here across lots of different fleets, and we're working with other colleagues in the industry as well on that.
So we're introducing this into passenger service today. It's running for the first time. It's carrying customers and people with the reception and launch party. We're really keen to understand how it performs in real life operations, and in parallel we're working on the business case to look at how we can convert more of these trains in the future. That business case is going to take a few months, as is the trial, so hopefully around about the summertime we'll be able to see what's going to happen next.
So we started this project, I think in 2018. We discussed with Porterbook and also a couple other customers regarding, installing this hybrid technology in the train. Back then it was really a pioneer work, and so we're very happy that today that kind of dream and all the groundwork that we did in the past years have really come into reality, and that's really exciting.
This battery hybrid trial is massively important for Chiltern Railways. We are currently operating an old diesel fleet of trains. We've got one of the oldest fleets in the industry, and we're determined to modernise and to decarbonise Chiltern. So this trial is massively important for us. It could be a very powerful way forward for us to modernise and decarbonise this railway.
So that was about 12 months ago, brings us up to date. There's no points for anybody who spots we were recording that on a passenger service, but in the quiet zone of the train. Thankfully, we didn't get any customer complaints for making noise when we were recording our interviews, but that was it. 10th of February last year. So yes, there's been some, as you would expect with new technology and a trial, some technical challenges on fleet reliability, but the unit has proven its fuel saving, the reduction in the emissions both of noise and pollutants, and performed pretty well over the past 12 months. So we're really pleased about that. As I mentioned earlier, there are over 500 Turbostar vehicles in operation, so HybridFLEX could be applied to many of those, and equally other more modern DMUs that have recently been built and introduced into service. So the technology could apply to those equally. All of this presentation has been about HybridFLEX. I did mention at the beginning our Class 165 hybrid trial, which was different technology, a bit more complex, more of a Toyota Prius solution, if you would, where the train would always run off batteries, but the batteries would be charged by a running diesel engine. Unfortunately, that's suffered quite a few technical issues and some delays. And at the moment, we're really evaluating, is it still a credible solution for Class 165s, given the remaining life of those units? So hence I've mainly spoken about, well, almost all spoke about HybridFLEX today. So that is all I would like to share with you. Thank you. I'm assuming everybody's been patiently listening whilst I've been talking to my computer screen, but thank you for listening. If there's any questions, I'll be more than happy to try and answer.
So what I wanted to do was just on behalf of the Milton Keynes Centre was to say thanks for coming along, Ian. I think it's been a really interesting session for me, because whenever I think of hybrid, I'm almost geared to thinking towards automotive. I think, I don't know if anyone else around the room's the same, but because we've seen it so much in the automotive world, you almost think about that and you forget about where we can use it elsewhere. I think one of the points that was really key to me was the engagement with the local residents. I remember when I was working with Chiltern back in 2012, we were looking at the fitment of the generators to the DVTs for a very similar reason.
Yeah.
That when they were looking to store the units at Marylebone, there were those difficulties with the local residents. So there's so many factors that need to be juggled with, I think, which I found it interesting. And also the sheer power increase as well. So when you mentioned that the old system's got 315 kilowatts versus the diesel engine's still 315, but you've got 150 kilowatts now, which may be a question for the future is, can we shorten journey times? Are we looking at decarbonisation in isolation, or could we also look at journey times, opening up to new routes and so on? So it's certainly given me a hell of a lot to think about. So once again, I think on behalf of everyone here and online, I just wanted to say thanks very much for coming along. Thanks to everyone online as well.